Hi everyone, this is the sixth video of our series called Essential Skills for Mechanical Engineers. In this video, we are going to talk about Computational Fluid Dynamics or CFD. Computational Fluid Dynamics is the process of mathematically predicting physical fluid flow by solving the governing equations using computational power. CFD is a tool that can be used to simulate fluid flow and heat transfer. It is often used in engineering applications to predict how a system will perform under different conditions. CFD can be used to optimize designs, troubleshoot problems, and understand complex phenomena. In a CFD software analysis, fluid flow and its associated physical properties such as velocity, pressure, viscosity, density, and temperature are calculated based on defined operating conditions. In order to arrive at an accurate physical solution, these qualities are calculated simultaneously. The main structure of thermofluids examination is directed by governing equations that are based on the conservation law of fluids' physical properties. The basic equations are the three laws of conservation. The law of conservation of mass, that is continuity equation, the law of conservation of momentum, that is Newton's second law, and the law of conservation of energy, that is first law of thermodynamics or energy equation. These principles state that mass, momentum, and energy are stable constants within a closed system. In short, everything must be conserved. CFD engineers are responsible for developing and applying computational fluid dynamics models to a variety of engineering problems. They must have a strong understanding of fluid mechanics, mathematics, and computer science. In addition, CFD engineers must be able to effectively communicate their findings to other engineers and scientists. CFD applies majorly to the areas of automotive and aerospace, production and manufacturing industries, turbomachinery, thermal and nuclear power plant, combustion, fire and environmental pollution, heating and ventilation of buildings, cars, buses and civil aircraft, weather forecasting, defense and space applications, and biomedical applications as well. Now we come to the top skills that you need to have if you want to become a CFD engineer. CAD. Computer-aided design is an essential skill for CFD engineers as it allows them to create accurate models of the objects they are simulating. Without CAD, it would be very difficult to create accurate CFD simulations. Second is programming. CFD engineers use programming to create models and simulations of fluid flow. This helps them to understand how fluids will behave in real-world situations and to design better products and systems. Matlab, Fortran, C++ and Python are programming softwares used in CFD. Third is numerical analysis. Numerical analysis is the study of algorithms for solving mathematical problems. In particular, it is concerned with the accuracy and efficiency of these algorithms. As a CFD engineer, you will need to be able to design and implement efficient numerical algorithms for solving the complex mathematical problems involved in simulating fluid flow. StarCD, Fluent, OpenFOAM are CFD solvers commonly used by CFD engineers. Fourth is CAE. CAE stands for Computer Aided Engineering. This is a type of software that is used to help engineers design and analyze products. CAE software can be used to create models and simulations of how a product will behave in different environments. It can also be used to test different design options and to optimize the design for performance or cost. FEA or finite element analysis is a numerical method used to solve problems in engineering. It can be used to find the stresses and strains in a structure or to determine the response of a structure to external forces. FEA is an important tool for CFD engineers as it can be used to verify the accuracy of their results. ANSYS is generally used for this purpose. Sixth is fluid mechanics. Fluid mechanics is the study of how fluids move and interact with each other and their surroundings. It is critical skill for an engineer who works with fluids, whether it is in the designing of plumbing systems, HVAC systems or automotive engines. A good understanding of fluid mechanics is essential for predicting the behavior of fluids under various conditions and designing systems that can safely and efficiently handle them. To accurately predict fluid flow behavior, a CFD engineer needs to be aware of multiphase flow and turbulence modeling. Multiphase flow is the simulation of flow of two or more phases of matter. It is a common occurrence in nature and is used extensively in many industrial applications. A CFD engineer needs to be able to model multiphase flow in order to accurately simulate real-world phenomena. This skill is important for many reasons, including the fact that multiphase physics can often be complex and difficult to predict. Turbulence modeling is a technique used to predict fluid flow behavior in situations where the flow is turbulent. Turbulent flow is characterized by chaotic, unpredictable motion. It can occur when fluid encounters an obstacle or when it flows through a constricted space. Turbulent modeling is necessary in order to accurately predict the behavior of fluids in these situations. Next is thermal analysis. Thermal analysis is the study of how heat flows through and is stored in materials. It is used to predict the behavior of materials under various conditions, including high temperatures. Thermal analysis can be used to determine the thermal conductivity of materials, the thermal expansion of solids and the melting point of metals. It can also be used to study phase changes such as vaporization of liquids. For accurate thermal analysis, a CFD engineer should be familiar with the concepts of combustion and conjugate heat transfer. CFD engineers need to be able to model and simulate combustion processes in order to design and optimize combustion systems. This requires a strong understanding of physics of combustion as well as experience within CFD software. Conjugate heat transfer is the study of heat transfer between two or more bodies that are in contact with each other. This is a branch of thermodynamics that deals with the transfer of heat between solid bodies, fluid bodies, and gaseous bodies. Knowledge of thermodynamics and heat transfer concepts like sensible heat, latent heat, specific heat, and ton of refrigeration are extremely important for this. At UpSchool, we have expert mentors who train these skills and help you get into your dream job. Thanks for watching this video. See you in the next one.